I'm very happy to be this year at ClueCon, this special anniversary edition. I'm happy to meet many of you this time, this year here. The next almost 20, 30 minutes, the next 20 minutes plus questions, I'm going to take you through the world of mobile networks and see where this meet voice over IP. So, a few details about me. I'm a senior researcher at Technische Universität Berlin in Germany. At the chair called Next Generation Networks, led by Professor Thomas Magedans. My research area is 5G beyond 6G networks, with a focus on core networks and application layer services. But we do have in our team end-to-end view on the entire 5G system by deploying research testbeds and building blueprints for 5G campus networks. In a larger context, my chair at Technische Universität Berlin teams up with 16 other German academic partners, universities, and research institutes across Germany, and we team up in a quite large research project called Open 6G Hub, and this is coordinated by the German Research Center for Artificial Intelligence. You see already from this constellation that AI is going to shape also the 6G. A part of being a researcher, I'm also co-founder of Kamailio project. I'm active in VoIP since 2003 and managing director of Asypto GmbH, a company established in Berlin, Germany. Let's go to mobile network technologies. Our lab at Technische Universität Berlin is having as main goals to build low-cost mobile networks testbed for teaching and research, and building teaching materials, prototypes that help us with easier onboarding of new students, and not only students, on this very complex field of mobile network technologies. And yeah, we were involved, or my team was involved, better said, in many generations of mobile networks. So now we like to say we are doing research and towards 6G, but we are building test beds with technologies from 4G to 5G and beyond. So we have on this slide the main building blocks of the 5G system: the user equipment, the radio access network, the core network, and application functions. And in our endeavor to build with a low budget testbeds for 5G core networks, we were looking at open source projects that we have available in this space. And I have to say, we are lucky today because over the last decade, network function virtualization and software-defined networks lived such a good evolution that opened doors to open source in a world that was reserved to big mobile operators. And yeah, here we have a set of open source projects that we use in our setups at the university. But I have to give you more details here. It's not only the open source project that have helped us with having now affordable test beds. It's also the availability these days of low-cost radio units, and also, very important in the last years, availability of spectrum for private 5G. So you can apply for licensing in Germany already since 2019. Germany was one of the front runners in introducing this allocation of 5G spectrum for businesses, not only the public mobile operators. But before diving into the open source project and seeing it one by one, I'd like to give you an idea what means from the equipment perspective to build such a testbed. So we need smartphones, but not any smartphones will do the job. It has to be 5G standalone mode compatible, and it has to support the 5G bands that are available in each of our countries. So having identified one such phone that is working in your local country conditions, we need also SIM cards. This is not such an issue. We have, for example, here Sysmocom cards. Okay, I'm not doing advertising anything, but these guys are doing a very good job. And they are also creators of an open source project that is used to program these cards. The prices are displayed there. You see it's not a huge amount involved. Going further to the 5G cell, because there is also where we need some physical devices. The good thing is that today we can have network functions running on generic hardware, so we need just a computer where the base station software is going to run, and then we'll pair it up with the radio unit, the white box in this picture, that these days you can find it to purchase from, for example, this box here is from National Instrument. It's an USRP B210, technically speaking. It's, from my point of view, the entry level for doing research. They are designed for research only, so you cannot build a commercial deployment with these toys. Just for you to have an idea on the radiation power, because there's discussion, okay, 5G waves, are they healthy, are they not healthy? The radiated maximum power with such a device is comparable with that of a Wi-Fi setup in 2.4 gigahertz. We are talking for Wi-Fi for a radiated power of about 100 milliwatts, but in the 5 gigahertz we are already talking about 20 milliwatts. This is something so tiny compared to the standard base station for 5G, where we are talking about 60, 80 watts, and the small cells, okay, 2 to 10 watts. So we see these are just tiny setups, but still very good for the research and education. So let's recap a bit. We have seen the user equipment prices. We have to top this up with prices for licensing, and I give you an example from Germany. They start around 1,500 euro. On this slide, there is even a formula how to calculate these fees in Germany, depending on the type of network that you want to deploy. No. Yeah, and now we have seen what means to build 5G testbeds from the perspective of the infrastructure, so of the physical devices. Now let's move towards the open source projects and see what we could use. What kind of open source are today available? I'll start with the simulators first. So we don't need an over-the-air setup. You don't need any private spectrum allocation. URANSIM, as the name also says, is a simulator for UE and for radio access network. The communication between the two components of the 5G system is done over UDP protocol, and these simulators are very good for testing, for example, the functionality of a core network function. To test the functionality of a core network function in over-the-air setup makes it quite time-consuming because you don't know where the errors can come from, and communication over the air is not always stable. So, yeah. Another open source project that I found very useful is 5G Linai, which is actually a module for 5G new radio implementation, so implementing the 5G network stack, but it comes as a module for the NS3 network simulator. And this is a really comprehensive simulation environment, from application layer to physical layer. It's supporting 5G non-standalone. For those of you that already have a background, this means actually you have only the radio access, so the antennas are 5G, but the core network is still 4G. It's very good for simulating the radio parts, for doing research on radio part on the radio layer of the 5G system, or if you want to play with the high band frequencies, these above 24 gigahertz that are called millimeter wave in 5G. Right now, at least in Germany, we have 5G, but the frequencies that are used are called sub-6 gigahertz. In USA, you already have this millimeter wave, but probably not on a very wide scale, but still you have them available from public operators. In Europe, they are not ready for public from public operators, but they just announced in the recent months experimental setups for industrial customers. Okay, I'll go to the next open source project, that is Open Air Interface, and this is the implementation of a base station. If you pair it with a radio board, you have a 5G cell. You can use it also without over-the-air setup, using the simulator that comes with it, simulator for the radio board and simulator for the UEs. Very useful if you have to do research where a large number of UEs are required. It's Open RAN compliant, but this is another story, and you can approach me in the breaks if you want to learn more about this new concept. PySim is the open source project used to reprogram the SIM cards with the subscribers' details that our network needs. SRS-RAN is also an implementation of a base station. It can be used also in a simulated mode, where the communication, instead of over-the-air setup, is using sockets, in this case 0MQ library. Open5GS is a good implementation of 5G core network. It's actually 2-in-1, is a 4G core network also available. What's in green are the components of a 4G core network, and what's in pink or red, it's a 5G core network. Another open source implementation of a 5G core network is Free5GC, also widely used in academia. And then Kamailio, it's the SIP server implementation used over the last 20 years in wide large VoIP deployments. Its feature is scalable, flexible, stable, and very important for us, for our use case. It has IMS extensions since over 10 years ago. This project comes at the heart of an IMS platform, and we will see in the slides following. Okay, free switch. Everybody in this room probably know what's free switch. Widely deployed since 2018 VoIP in private 5G, could be used as telephony application services or media services. A TUB AV chair in our 5G lab, we are using free switch from generic media services availability for our students using the 5G playground to more advanced scenarios, for example, integrating mission critical and push-to-talk services to 5G and 6G networks. Our role at university is to make the life easier for our students, so to onboard the students, but not only the students, to onboard the research partners in the large research project, national or international. So therefore we need blueprints that we can share with them. And for example, we can have a blueprint of a minimal private 5G network where only data connectivity is our goal. We see it in pictures, the main components that realize this kind of network, and then we see the result. The phone is connected to 5G. We can access the data network, we can watch YouTube. Or we can have the blueprint of a private 5G network that integrates also voice services. Here it's sketched a testbed for such a network, powered by example by Kamailio Open 5GS, Python HSS, Open and SRS RAN on the computer. I spent 3 minutes to show you how such a setup is working. For example, this is a demo of the voice over new radio service that is running over such a small 5G setup. The phones were on airplane first, and they got attached to the 5G network. And then we see the register, SIP register, that the phones got registered with the IMS platform. And now we are placing a call. If all fine, it should ring. Yeah, it rings. We can see the SIP flow during the call, and we test for audio. Audio is working. That was a demo that actually we presented live in April at a one-day event that my chair organized at Technischen Universität Berlin. And the video was actually thought to be a backup just in case we have issue with the over-the-air setup, but there was no issue, so the video came not to be used. Thank you, Fred, for helping with taking the video on the fly. And now, actually, we are testing SMS over new radio. So we are trying to send an SMS and wait to see if it's going to be received by the second phone. It takes some time because it's an SMS sender that it's store and forward. and from time to time it delivers the messages. And I think more or less this is the entire demo. Now it's tested also the other direction of sending SMSs. And I think we should move forward because the time is pressing. Yeah, so after we saw at work such a small setup, let's look a bit closer to the architecture of multimedia services enabled private 5G network. And if we focus on the IMS box, which is actually responsible for the voice service integration, we can see strange names for people without background. First, these are the components as they were defined by 3GPP. We have a proxy call session control function, interrogating call session control function, serving call session control function. We have telephony application server. So where do you think the open source project responsible for voice could come into play? We see it on this slide. So free switch could be used to instantiate these boxes, two boxes, the telephony application server, or to handle media services. And Kamailio is used to instantiate the call session control function components. Okay. So once we deploy such a testbed, it becomes an open experimental field. We dissecate this in all directions. We are solving issues that if we have them, we do traffic analysis, spectrogram view, and we try to evaluate the performances that we can achieve with such a setup. For example, we measure different KPIs. I have plotted here the call setup time in the case of voice over new radio with the prototype that you saw in the demo. We observed that the QoS mechanism of the 5G core network requires approximately 800 milliseconds to reserve the dedicated radio resources for voice over IP, because voice over IP multimedia services are treated with different kind of QoS, so it needs special reservation of resources. And also a plot regarding max jitter or min jitter for the RTP streams established during the vulnerable calls, and we experienced a mean jitter under 20 milliseconds, which is still acceptable because anything under 30 milliseconds is acceptable in VoIP, not to affect the quality of the audio. So with this, we approach to the end of my presentation. If you want to find out more about our activities, we have a website, tu.berlin/AV. Okay, for English, it's another slash there, but yeah, okay. And you can also read about our results in the papers my research team published. We have seen what it means to build with open source small 5G testbeds, what their prices, what their costs are, and what projects could be used. We saw a demo, so I think you have now a good introduction if you would like to embark on this journey of mobile network prototyping or services, adding services for such a network. I want to thank you all for your attention. Thank you, Free Switch team and Signal Wire team, for having me here this year. And if you have questions related to open source and mobile networks, I am here.
Thank you, Ramona.
Thank you.
And we do have an opportunity for questions. That is democratization, isn't it? Being able to build your own standalone 5G network out of open source components, lowering that barrier to entry. What questions have we got for Ramona? Okay, we'll come to you, young man. Our gummy bear man, Michael. He's still got the gummy bears. Thank you.
All right, so you covered the costs of doing that as far as the hardware you need, SIM cards, phones, things like that. Like a major cost of these types of deployments, though, is the engineering hours behind getting all of this set up and doing the custom integration and stuff. Do you have any estimates on how much man hours that took and how large the team was that actually did the integrations and configurations on that setup?
Well, a very good question. Yeah, I don't have an estimation. I'll try something else. I have to say it's pretty complex, and you need a good background, or you need a good starting point. So engineers that you could ask for advice or kind of blueprints that will help you on this journey. So it is a really complex field, I have to say. I don't know how many hours, but probably 1 year is going to take to understand what 4G, 5G is. But if you have a background on networking, it will speed up a lot. Yeah, I have to warn you, it's damn complex. If you start from scratch, it takes several months. But okay, if you have a bigger team, you can reduce this time.
Thank you, Ramona. More questions for Ramona? Oh, sorry, I almost missed you.
You mentioned reprogramming SIM cards, but is it possible to use eSIM instead?
eSIMs, it is possible to use, but for private 5G networks, this time they don't make too much sense because it's about their third-party administration, and you have to think these private 5G networks serve only a few €100, 100, 300 euros, and it doesn't pay off this third-party administration. So the costs incurred with the administration of the SIM card for you as operator of this small network are pretty high. So it doesn't make any sense right now, but probably in 3 years we'll have a different situation.
Thanks.
Thank you, sir, and thank you, Ramona. Okay, yes, we got another question up here with Diego.
Thank you, Ramona. Very interesting presentation. I was wondering what kind of voice or video codecs you are using for testing the standard ones provided by Switch. Any special ones?
Actually, we cannot influence too much these voice codecs right now because we are stuck with what our smartphones can do. And I can tell you from our experiments right now for voice over new radio, for example, the Nokia X30 is using AMR. And okay, if you use it in an over-the-top voice scenario, the Opus is used. So it depends only on the end-user devices.
Great, thank you, Diego. Any more questions for Ramona? Yes. Is that 2? Ah, okay. I'll come to you in a minute, Jack. We'll go to Bianca here. Bianca's also a mobile lady.
Mine is not a question, but James told me to say to people that we have 5GSA eSIMs And find me later, and I can walk you through that.
Thank you for that contribution, Bianca. Here we are, Jack.
So, Ramona, thank you very much. I just really didn't know anything about this, so I really appreciate the learning. Are you familiar with CBRS in the United States?
CBRS, I think it's that public or...
It's unlicensed 3.5G cellular spectrum. And big companies like Nokia and Ericsson are selling 5G solutions for private wireless in that network. But there's also vendors who are building open source 5G private networks into that spectrum. And I was wondering if you've seen any of those vendors, they're very small startup companies that you've never heard of, using open source components to make 5G private networks for CBRS. So I was wondering if you'd seen that. My guess is there's something similar going on in Germany. I just don't know. I haven't heard of it. And I was wondering if there's anything you've learned from that or if you could make comparisons.
There are activities of making 5G networks in unlicensed spectrum, especially in USA, this CBRS, how it's called. But still some time needed here because you have to be lucky to find a user device, so a smartphone, that is able to handle exactly this band, this frequency, because the smartphones support certain bands. And if the band covered by CBRS is not supported by the user devices, then you cannot do anything. So you can do something, but not testing with smartphones. You can test with simulators. Okay, not the ones that simulate the communication over UDP, but what I mean the simulators, you can have from SRS-RAN, for example, also not just a RAN as software, you can have also a UE, a smartphone as software. And then you pair this UE with the STR, with the radio board, and you got a kind of smartphone, a bigger smartphone. And then you can set it theoretically on any frequency you want, but practically it might be a different situation because not all frequencies are supported by these simulators. SRS-RAN has a simulator, and OpenAir interface has also a simulator.
Very good, thank you.
You're welcome.
Thank you, Ramona.